in the last lecture, we have designed the toe slab. Okay, so we have designed the toe slab, and what reinforcement we have provided for the toe slab? We have provided 12 diameter bars. Okay, we have provided 12 diameter bars above 160 center to center. Okay, so this was our reinforcement for the toe slab. Okay, stem we have already designed, and toe slab also already designed. Now we will design the hill slab. Okay, so three main parts are there of the retaining wall. See, you understand these things. Three main parts are there. First is you have to design the stem. Second, you are going to design the toe slab. Third, you are going to design the hill slab. That's it. Okay. And before designing all these three, first you need to take the check of stability. Okay. In the stability check, you see that what is the eccentricity, and that eccentricity should be less than b by 6. Okay. So no tension is created at the base. That is the condition. Okay. So now next is the design of hill slab. So we will see how to design the hill slab. Design of hill slab. So today, if possible, after this design of hill slab and after the completion of this retaining wall, we will design one example for the water tank, which is frequently asked in the examination, circular water tank with flexible base. That example is always asked in the examination. So we will see that example. After that, our syllabus is over now. Okay, so this is the retaining wall last unit, sorry, second last unit, and after that one problem from the water tank. Okay, and after this now, I will provide you the Google Forms which consist of MCQs. Okay, maybe 5 to 10 MCQs are there per unit, and you have to solve those MCQs, and that I will take it as your test. Okay, and same MCQs will be there for your as your MCQ question bank. You can take those MCQs. Okay, take the screenshot of that Google form while you are giving the answer or after you are getting the correct answer. Okay, so now moving further, so we have to finish today this design of hill slab as well as the water tank so that we can wind up our syllabus. So now design of hill slab. Okay, so bending moment calculations for hill slab. Bending moment calculations calculations for for 1 meter wide strip 1 meter wide strip of hill slab. So we are assuming 1 meter wide strip for hill slab. You know that we have designed many slabs in DCS1. We always consider the width as equal to 1 meter. Same thing is applying we are over here. Okay. So I will draw the diagram first so that it will be easier to you for understand this. So this is your retaining wall. Okay, I will draw the small diagram, and the pressure intensity below the retaining wall, if I draw it, then it will be, here it is 39.54, and here the maximum pressure 177.94, I think. So if you join this is your pressure. This ordinate is 171.94, 94 or 74, I am confused. See the value 94 or 74, and this is 39.54. Okay, this is 1.6 meter. So when you are talking about hill slab, we will consider this point. Okay, let us consider this point as B. So from this point to B point, this is your hill slab. Okay, so we will consider the portion whatever comes here. So if I project this, so this is the line. So what pressure now we are going to consider? So the pressure, see, I will draw the diagram. On this area we will consider what is the pressure over here. Okay, To calculate the bending moment, we will consider now this much of area. Okay, this much of area, which I have shaded in blue portion. So now first thing is that we need to find out the this ordinate. What is this ordinate that we need to find out? We don't know. Let this ordinate be x. Okay, first of all we need to find out this ordinate. So to find out this ordinate, what we are going to do? We will drop a perpendicular. Now if I draw the diagram, separate diagram for your understanding. So now again this is our pressure distribution line. So here it is 39.54, here it is 171.94, and if I join these two, this will become our trapezoidal. Okay, and here it is 39.54. Okay, here it is 171.94. So this total length is 3 meter. You know that because the width we have taken as 3 meter. Okay, and we want the ordinate somewhere here. Okay, we want this ordinate somewhere here. So what we will do for that? First of all, we will drop perpendicular from this point. So we got perpendicular. We drop perpendicular from this point. Okay. So after dropping the perpendicular, this ordinate, this much of ordinate, how much it will be? It is 171.94 minus 39.54. Okay. So it is 132.4. This ordinate. Okay. So from this we can find out what is this ordinate. हा ordinate आपल्याला मिळेल by using this triangle. If you see this triangle, in this triangle this length is 3 meter. This total length is 3 meter and this ordinate is 130.32.4. So we can find out this. Okay, because we know the length. This length is 1.6 meter. Hill slab 1.6, here it is written 1.6. So I can say that for 3 meter the ordinate is 132.4. Okay, so for 1.6 meter, what is the ordinate? Okay, what is the ordinate? So if I do the cross multiplication, then it is 132.4 into 1.6 divided by 3. So that ordinate is 70.61. So this ordinate is 70.61. Okay, हा ordinate तुम्हाला मिळाला 70.61. Okay, and what is this ordinate? This ordinate is already known to you. इथनं इथपर्यंतचा ordinate किती आहे हा एवढा किती? It is 39.54. Okay, it is 39.54. So here you can see, here if you draw the perpendicular, I will use a different color, this perpendicular. Okay, this is the perpendicular. So this ordinate is 70.61, and this ordinate you know that it is 39.54. Okay, so I hope now how we have calculated the ordinates it is clear. We have already done this in stem also. We have done this in toe slab. Okay, so now if you don't understand in toe slab, now you can understood over here. So now if I give the name, if I give the name, suppose that this is again I will use different color. This is A, this is A, this is B. Okay, suppose this is I, this is G, and this is H. Now you can see that rectangle ABIH is the one area, and triangle IGH, this is G. Triangle IGH, this point is G, this point is I, and this point is H. Triangle IGH. So these two areas are there. This is area number 1, this is area number 2, which are exerting upward pressure. which are exerting upward pressure. आता बघ हे upward pressure देणारे झाले. Downward pressure कोणाकोणाचा असणार आहे? Who will give you the downward pressure? Then the downward pressure will be this much is the area of this hill slab. याचा काहीतरी dead load असणार आहे का नाही? Okay, so that dead load will act downward. Okay, dead load of hill slab. Okay, plus here soil is present. Okay, here soil is there. Soil is retained over here. Okay, so for that here the pressure of the soil we need to consider. Okay, so this is dead load, and from downward this is the soil pressure or soil weight you can say. So these two loads are moving down on the hill slab, and here these two areas, which is one is rectangle, one is triangle, these are moving up. So all these we are going to consider while drawing the bending moment diagram. So I will give you the heading over here: load, loads due to. This is my first column. This is my first column. Okay. Second will be magnitude. Magnitude in kilonewton. And this is my second column. Then third one is distance from point B. Distance from point B. Okay, in meters. I have already shown where is the point B. Point B is the corner point of hill slab. Here we have shown. See, this is our point B. Okay. This point is our point B. Hill slab point. Okay, at this point we are going to take the moment of all the forces about this point B. And now after this, next is the moment in kilonewton meter. Okay, so this is our table. So now we will start first. That is the dead load of hill slab. Okay, first dead load of hill slab. So what is the dead load of hill slab? So here you can see what is the length. It is 1.6. Okay, so the length is 1.6. This depth we have already designed, it is 0.4 meter. Whatever may be the thickness of stem at bottom, same we will provide as a depth of base slab. Okay, so this is 0.4. So 1 into zero point 0.4 into 25. So it will be 1.6 into zero point 0.4 into 25. So what is this value? So it will become 16. Okay. So the distance from point B, what is the distance now? See here, this is 1.6. This total is 1.6. This total is 1.6. So this load will act at the CG of this. So this is rectangle. So CG is at a distance of B by 20 by 2. So B by 2 means 1.6 divided by 2. So it will be 0.8. So this is 0.8. And the value is 12.8. Okay. The value is 12.8. Okay. So the second thing, soil soil backing. Soil will be there. Okay, which is resting on hill slab. On toe slab there will not be any soil. Remember this. This is your toe slab. हा पुढचा भाग आहे इथं कधी सॉइल नसणार आहे. सॉइल ही पाठीमागे असणार आहे रिटेन करायसाठी. So the pressure of the weight of the soil will act on this hill slab. Okay. So now for soil backing it is so we need to see that see this height from this point. This height is how much? We have already calculated this height is 5 meter. Okay, and what is the this width of this base slab? It is 1.6 meter. So this is a rectangle of 1.6 meter by 5 meter. So here it is 1.6 into 5 into, so we have to consider it is soil, so unit weight of soil, it is 18. If you solve this, you will get the value as 144. Okay, 144. Again, the distance of CG will be same because width is 1.6. So this moment is 115 point. Okay. So now the third thing, upward pressure. So both these are the downward pressure. So you can see the direction. Okay. This is clockwise. This is clockwise. If you consider clockwise plus, then these moments are plus. Upward, upward movements means for the upward pressure it is moving anti-clockwise. So this you can consider both of them as plus, no problem. Okay, this is also plus, this is also plus. Sign conventions are just we are using over here for the algebraic sum, nothing more than that. So here now upward pressure. Okay. So upward pressure कुणा कुणाचा असणार आहे? First ABIH. Okay, ABHI. This is the rectangle. You can see here ABIH. Okay, so ABIH is the rectangle. Its ordinate is 39.54. Its ordinate is 39.54, and this length is 1.6. Okay, this length is 1.6, and this is 39.54. This is rectangle. So you can take this as 39.54 into 1.6. Okay, so it is per meter width. Okay, so divided it is per meter width, so divided by 1. So now here you can do this calculation, 39.54 into 1.6. So how much it is? 63.26. Okay, and the CG will be same as the distance is 1.6. CG will be same because this is 1.6. हे 1.6 आहे तुमचं, तर याच्या सेंटरला येणार म्हणजे 0.8 बी पासून 0.8 वर. So answer into 0.8 if we do is 50.61. This is 50.61. It is moving in anti-clockwise direction, so minus. Next. Next is your triangle IGH. Triangle is IGH. So now if you see this triangle, now if I want to calculate the area of this triangle, it is half into base into height. So this height is 70.61, base is 1.6. Okay, so it is half into base is 1.6 into height is 70.61. Okay. So half into base into height, so that you will get the answer as 56.48. 56.48. Now see the CG. Okay, आता याचा CG बघा. So if I draw this triangle over here, now this is the triangle. Okay, this total is 1.6 meter. This is 70.61. Your point B is here somewhere. So this is 90 degree. So the CG of this triangle will be here at this point, and from here the upward pressure will act. इथून तुमचा upward pressure act होणार आहे. ओके, आणि हे प्रेशर किती असणार आहे तर आत्ताच तुम्ही कॅल्क्युलेट केलेले आहे. इथे हाफ इंटू 1.6 इंटू 70.61 एवढा असणार. ओके, but this distance of this CG now from right angle it should be at a distance of b by 3. So it is equal to 1.6 divided by 3, which is equal to 0.53. 0.53. Okay, so this is the CG. Again it will rotate. If you rotate this about this point, it is anti-clockwise. So here it is 0.533. It is 56.48. So answer is 30.12 negative. So the total moment now we are going to calculate. So the total moment is 47.27. Okay. So it is 47.27 kilonewton meter. So this is our total moment. Now our problem will become easy. Once we find out the bending moment, it will be very easier for us. We are going to provide the steel now. Okay. So here again consider consider effective cover effective cover for base slab for base slab is, again we will consider effective cover as 40 mm. So we know that depth is equal to how much? It is 400 mm. So therefore effective depth D is equal to 400 minus 40, which is 360 mm. So calculate the area of steel now. AST. AST is equal to, you know the formula. Let me know the value. You know the formula. You know the bending moment. You know every value. You know small d 360. So just put the values and let me know the answer. Now I will directly write here. Point 0.5. Okay, point 0.5 FCK. What is the value of FCK? M20 is given or M25 is given. M20. Okay. So 0.5 FCK BD. Okay. 0.5 FCK BD. D is 1000 into D is 360 whole divided by Fy in bracket 1 minus square root of 1 minus 4.6 mu 47 point how much? 27 into 10 to the power 6 divided by FCK BD square. Therefore, AST is equal to the calculations. Let me know the answer. 371.82. 371 point, other split check the answer. 371.82 mm square. This is the answer. This is the area of steel. Okay. Now we will calculate AST minimum. Minimum steel required over here. Minimum steel is nothing but distribution steel. So AST minimum म्हणजे एवढं तरी स्टील तुम्ही टाकायलाच पाहिजे. मिनिमम स्टील पेक्षा आपलं जर AST जास्त असेल, okay, if our AST is greater than AST minimum, then this AST we will provide. But if our area of steel which we have calculated 371.82 is less than this AST minimum, okay, then we should provide AST minimum. So we will calculate this. For Fe415 it is 12% of gross area. So 0.12 divided by 100 into gross area B is 1000 into D is 400. Here capital D we always use. To calculate this value, let me know the answer. Answer is 480. Okay. So now see here. Minimum steel is greater than the AST minimum. Here AST minimum, which is equal to 480 mm square, is greater than AST, which is equal to how much? This AST is equal to 371.82 mm square. Okay, Michaelizer. Therefore, take AST is equal to 480 mm square. So we will take this value now. Now consider 12 mm bar diameter. Okay, assume 12 mm dia bars. Calculate the number of bars first. Number of bars is equal to, that is 480 divided by pi by 4 into 12 square. Calculate this. So 5 bars, 4.24. 4.24, which is nearly equal to 5 numbers. So AST provided. How much AST we are providing? So we are providing 5 bars, each of diameter 12 mm. Calculate this. Five 65.48. 565.48 mm square. Okay. So this is the AST provided. Now calculate the spacing. So spacing S is equal to area of single bar divided by AST provided multiplied by width. So let me know the answer. 200. Okay. So it is 200 mm center to center. So here we can say provide 5 bars 12 mm diameter about 200 mm center to center for hill slab. For hill slab. Okay. So this is where now the design is finished. Now we will take the check for sliding, which is the important check over here. Okay. So now this is the design of hill slab. These steps you already know. Number of bars, AST provided, spacing. It now it is very easy for you. So now next is check for sliding. This check always we take. Okay. So horizontal pressure we will calculate first, which is acting on the wall. Okay. So horizontal soil pressure we will calculate first. Okay. So horizontal soil pressure P is equal to किती असणार आहे horizontal soil pressure. See, if I draw the line diagram of this, suppose this is your retaining wall. Okay, this is your retaining wall. This is the ground level. Horizontal soil pressure. Okay, so I'm trying to explain you the horizontal soil pressure. Suppose this is our retaining wall. Total height of 5.4 meter. This is the retaining wall, and this is your ground level. Here, this is your ground level. Okay, or below the ground level. Okay, ground level will be somewhere here up. So now this will be the pressure of the soil. Okay, and it will acting like this. This is your pressure P. Okay, this your total height. This total height of this pressure, it is 5.4 meter total height. Okay, now this base, what is this base? This base is Ka into gamma into H. This you have already learned. Okay, and this area of triangle will give you the pressure P. Okay, area of triangle will give you the pressure P. So here I will write horizontal horizontal soil pressure P is equal to, what is the area of this triangle? Half into Ka into gamma into H into, this is also H height na, into H, half into base into height. Yeah. So if you put the values over here, then it is, here I will put, it is half to K is 0.33 into gamma is 18, okay, into H is 5.4, into H it is again 5.4. Now solve this and let me know the answer. Now this is our horizontal soil pressure. Okay. Now after this, calculate the limiting friction. Okay. So limiting friction, you know that you have studied the friction. F is equal to mu into R, where mu is the coefficient of friction and R is the normal reaction. ओके, हे तुम्हाला ऑलरेडी सगळं झालेलं आहे. अप्लाइड मेकॅनिक्स मध्ये तुम्ही शिकलेला आहात. सपोज दिस इज द सरफेस. ओके, अँड नाउ सपोज द फ्रिक्शनल फोर्स इज ऍक्टिंग in this direction. This is your frictional force. This is your frictional force F. Then how do we calculate the limiting? And suppose the normal reaction R, it is acting in this direction. This is your normal reaction R. Okay, and the coefficient of friction for this surface, it is suppose mu. So you know that F is equal to what? Mu into R is equal to what? Mu into R. Okay, so similarly now, so suppose this box is kept over here. Okay, the weight of this box is W, which acts vertically downward. I suppose this is the weight of the box. Suppose now this is the weight which is acting vertically down through the CG. Okay, W. And suppose this is the normal reaction R. So your normal reaction is always acting opposite to the weight. So in this way your normal reaction will be acting. Okay, R. R. So if you apply the summation Fy equal to 0, then you will get this W is get balanced by this reaction R. So here also we can use, here we can say that F is equal to mu into R, which is nothing but mu into W. Okay. So this is the concept from friction. Okay, from the chapter friction. You will get this concept in detail in applied mechanics book. Okay. So now limiting friction. So I will calculate the friction now. Limiting friction, which is equal to mu into R, which is equal to mu into W. Okay. So but we don't know the value of mu. So we will assume mu is equal to 0.65. You can assume this value 0.65 for mu. Okay, for retaining wall, assume it 0.65. So now we will calculate the value mu W upon P. So mu W upon P is equal to, it is 0.65 into W. W means what? Total load. Total load we have calculated in stability check First table, go to the first table which we have calculated at the start. In that we have taken all the weights W1, W2, W3. Okay, so there you will find this weight 211.5. Okay, and divided by P. P just now you have calculated 86 point how much 60 something like that. So now calculate this value. This value should be greater than 1.55. This value must be greater than 1.55. तुमची greater यायला पाहिजे ही value 1.59. Okay, so this value is 1.59. So this check is get satisfied when your mu w upon p is greater than 1.55. 1.55, it is safe. So in this way, the here we can provide design of retaining wall. In the design of retaining wall, there is one concept is there, shear key, but that concept is not there for you in such a detail. So here we can directly write provide depth of shear key as 200 mm. We will provide the depth of shear key at 200 mm, and finally we will draw the reinforcement diagram. This is called as shear key. Whatever I am showing over here, this is the bottom part. This is called as shear key. Now we will provide the reinforcement. So here is the bar first coming from this point. Then it will move towards this side. This is your first bar. Okay, this is 16 mm bar. What we have provided for this stem, I think 16 mm we have provided for the stem. So this is the bar in stem. Second also, this is also the bar in stem. It is provided like this. And come into the shear key. So this is the standard reinforcement. You have to keep in mind this reinforcement for retaining wall. Retaining wall design करताना नेहमी अशीच reinforcement provide केली जाते. You remember this. Okay. This way this bar is provided. This is the profile of this bar. Okay. So this is your bar in stem. This is maybe 16 mm. Please check the diameter. I don't remember the diameter. About 120 mm, I think, center to center. This is your shear key, and this depth is 200 mm. That we have taken at the last. It's called as shear key. And here, again at the bottom, the bar is also placed. Base slab bar. This is what we have designed for base slab. It was right now we have designed now. What was the spacing? 200 something. So 12 mm diameter bar, about 200 mm center to center. This bar is, and now we will provide the remaining steel. That is the distribution steel. Okay, for the same distribution steel what we have calculated, that we are now going to provide. This is the distribution steel. Draw this diagram as it is. In this way only the reinforcement is provided in the retaining wall. This is your 8 mm bar. Please check the bar diameter what we have taken for distribution steel. 8 mm or 10 mm. About 100 mm center. So this is your retaining wall. This is the diagram of retaining. So I hope now it is cleared with you. Take the screenshot of this. So you can write the dimensions over here. Whatever dimensions we have provided, you can write over here. This dimension and this dimension. Okay. This is also one dimension. This is also one dimension. Here you can write this is 0.2 meters. This is 0.4 meters. This is 1 meter. This is 1.6 meters. Okay. So in this way you can write. So this is the thickness of stem at bottom. This is the thickness. This thickness is how much? This is also 0.4 meters. The total height is 5.4 meters. Retaining wall. So for the total height from this point again, if you take the height from here, this point up to the top, okay, so this height is 5 meters. The total height is 5.4. So this is the design of retaining wall. Okay. So in the next lecture on Monday, we will take one numerical from water tank, and then all the things will be finished.